Hello. In this tutorial, we'll create an engaging grid-based game where you can place, merge, and swap units on a game board. The final result will feature a dynamic grid system with visual feedback, allowing players to drag and drop units, merge identical units to create higher-level ones, and strategically position units on the board. You'll see cells highlight in different colors to indicate valid placement options, merge opportunities, and invalid moves, along with visual and audio feedback to enhance the player experience. Let me show you all the files I've already set up. I have a level up sound effect, a simple level up Niagara system, and an enumerator with states, idle, valid drop, invalid drop, and can merge. I have an island mesh whose size is equal to the default Unreal Engine cube size. And this is its material. It has a color parameter for instance material changing. I have green, red, and white materials. This is the material for the unit base, which also has green, red, and white variants. Now let's begin setting up our game project. First, let's create two actors, cell actor and unit base actor. In the cell actor, add a static mesh component and assign the island mesh to it. In the unit base actor, add a skeletal mesh component and assign the mannequin mesh to it. Rotate the Z-axis to -90, then set the anim class to unarmed. Assign the material to it. Now in the cell actor, add the variables we need. Add a Boolean variable named isOccupied. Add a new variable named UnitBase and set its variable type to UnitBase object reference. Add a new variable named currentCellState with the variable type as cellState enumerator. Add a new variable UnitSpawnLocation with the variable type as vector. And add a new variable UnitStandLocation with the type as vector. In the begin play event, set the UnitSpawnLocation X to the current actor location X and Y to the current location Y, then add 1000 to Z. Set the UnitStandLocation variable the same way, but change Z by adding 50. Add a new function named getIsOccupied. Check if the unit base is valid. Set isOccupied to true. If it's not valid, set isOccupied to false. Combine with a reroute node and return the output function variable isOccupied. Add a new function named highlightCell. Drag the current cell state into the input function, then do a switch with the current cell state. Drag the static mesh component and call the setMaterial function. If it's the idle state, set the material to the white material. If it's the valid drop state, set the material to the green material. If it's the invalid drop state, set the material to the red material. If it's the can-merge state, set the material to the yellow material. Add a new function named setOccupiedUnit. Drag and drop the setUnitBase variable, then plug it into the input function. Check if it's valid. Set the current cell state to invalid drop. If it's not valid, set the current cell state to valid. In the unit base actor, add a new variable named SpawnLocation with the variable type as vector. Add a new variable named StamLocation with the same type. Then add a variable named AnimationDropTime. Add a variable named is dropping with the variable type as Boolean. Add a variable named cellStandOn with a variable type as cellObjectReference. Add a new function named setStartDropAnimation. Drag and drop the variables spawnLocation and standLocation. Then plug them into the input function. Set animation drop time to 0 and is dropping to true. Add a new function named callTickDropAnimation. Add an input function of type float named deltaTime. Set animation drop time by adding the deltaTime input to animation drop time. Create a local variable named animationDuration with a variable type as float and set it to 0.5. Check if animation drop time is greater than or equal to animation duration. If it's true, set the actor location to the standLocation variable. Then set is dropping to false. If it's false, do a lerp vector with spawn location as A and stand location as B, then use animation drop time divided by animation duration as alpha. Set this to the input of a new set actor location node. Add a variable named unitLevel with a variable type as integer. Set its value to 1. Add a new function named updateMaterial. Use unitLevel as the switch state. If unitLevel is in state 1, set the material to the white material. If unitLevel is in state 2, set the material to the green material. If unitLevel is in state 3, set the material to the red material. Change this element index to 1 because our skeletal mesh has 2 materials in it. Add a new function named upgradeUnit. Increment unitLevel by 1, then call the updateMaterial function. Add a new function named setOccupiedCell. Drag and drop the variable set of cellStandOn, then plug it into the input function. In the tick event, use is dropping to check if it's true, then call the tickDropAnimation function and set deltaTime to it. Create an actor named GridManager. Add variables of type integer named row and column. Add new variables of type float named cellSize and cellSpace. Add a variable named GridCells with a variable type as array of cellObjectReferences. Add a variable named currentCell with a variable type as cellObjectReference. Add a variable named targetCell with a variable type as cellObjectReference. Add a variable named currentUnit with a variable type as UnitBaseObjectReference. Add another variable with the same type named targetUnit. Add a variable named mouseLocation with a variable type of vector. Set row variable value to 3 and column set value to 6. Cell size set to 100 and cell spacing set to 50. Add a function named getGridStartLocation. Take the row variable, subtract 1, multiply with cell size, add with cell spacing, and multiply by 0.1. Duplicate it and change the row variable to the column variable. Create an actor location node, then subtract with the output results x and y already calculated. Set it as the output function vector. Add a function named getCell@index. Add two input variables of type integer named R and C. Take R multiplied by column, then add to C. Promote to a local variable named index. Check if grid cell from index is valid. If it is valid, copy grid cells from index and set it as the output function. Add a function named isValidGridIndex. Add two input functions of type integer named R and C. Check if R is greater than or equal to 0, and C is greater than or equal to 0. R is smaller than the row variable, and C is smaller than the column variable. Combine all B with N in Boolean node, then set it as the output function. Add a function named world to grid indices. Add an input function variable of type vector named worldLocation. Take the world position, subtract with the getGridStartLocation node, and split the output node. Take X and add cell size multiplied by 0.5. Then take the output result and divide by cell size plus cell spacing. Duplicate it and change from X variable to Y variable output. Take the X result and convert to floor. Do the same with the Y result, then plug them into a makeInPoint node for X and Y. Set the output function as the endpoint result. Create a new function named getCellFromWorldPosition. Add an input function of type vector named worldPosition. Take the world to grid indices node and plug in the worldPosition input node. Do a check from the isValidGridIndex node. If it's true, use getCellAtIndex to set as the output function. If false, set the output to empty. Add a function named createGrid. The first loop takes the row variable subtracts by 1 and sets it to the last index. Promote the index to a local variable named R. Take column subtract 1 and set it to the last index in loop. Promote the index to a local variable named C. Create a spawn actor from class node and set the spawn class to cell class. Take the local variable R multiplied by cell size and add cell spacing. Duplicate it, changing from our local variable to C local variable. Make this into a vector node, then add the start location node and set it into the spawn location. Use the gridCellsArray variable to add the element from the output spawn node. Now I want to test it to see if it works. First, we need to create a camera actor. Add a camera component and set it to root. In the begin_play event, use the getPlayerController node to call the setViewTarget with blend node. Set the new view target to self. Drag and drop the camera actor into the level and position it. In the Grid Manager Actor begin_play event, we need to call the createGrid function. Drag and drop the Grid Manager Actor into the level to test. Now the grid is cell-centered and nicely spaced. Delete the Grid Manager actor from the level. Back to the Grid Manager actor. Add a new function named Highlight Cell State. Check if current unit is valid. If it's valid, use the Grid Cells Array variable to call the ForEachLoop function node. Promote the array element to a local variable named cell. Drag from the array element and call the getIsOccupied function. Check if the cell is not occupied. If it's not occupied, set the cell state to valid drop. Do another check from the false output node. Check if current unit level is the same as the cell unit base level. If true, set the cell state to CanMerge state. If false, set the cell state to invalid drop state. Add a new function named ResetCellState. Use the GridCellsArray variable node to call the ForEachLoop function node. Drag from the array element output node, then call the HighlightCell function and set it to idle state. Add a new function named getFirstEmptyCell. Use the GridCellsArray variable to call the ForEachLoop function node. Promote to a local variable from the array element and name it EmptyCell. Check if the cell is not occupied. If it's not occupied, set the EmptyCell local variable in the output function. Add a new function named SpawnUnit. Use the getFirstEmptyCell node output to promote a local variable named EmptyCell. Create a SpawnActor node and set the class to UnitBase class. Use the UnitSpawnLocation vector node from the EmptyCell variable and set it into the spawn location. After spawning, use the EmptyCell to set occupied unit from the output spawn. Drag from the output UnitBase spawn and call the setStartDropAnimation function. Then set the unit spawn location and STAM location from the EmptyCell local variable. Drag from the output spawn node and call the setOccupiedCell function. Then set the EmptyCell variable into it. Add a new function named CanMoveToEmptyCell. Add an input function variable targetCell with the variable type as cellObjectReference. Check if targetCell is valid. Then check if targetCell is not occupied. Then set it as the output function. Add a function named CanMergeUnit. Add input function variables of type UnitBaseObjectReference named Unit1 and Unit2. Check if Unit1 and Unit2 are valid, and check if Unit1 and Unit2 have the same unit level. Also check if the unit level is smaller than the max level. In this case, I set max level to 3. Now bind with an Boolean node and set it as the output function. Add a function named canSwapUnit. Add input function variables of type UnitBaseObjectReference named Unit1 and Unit2. Check if both units are valid and if they don't have the same unit level. Combine with an Boolean node and set it as the output function. Add a function named moveToNewEmptyCell. Use the current unit variable to call setActorLocation. Use the UnitStandLocation variable for the target cell variable node to set the new location. Set the target cell occupied unit to the current unit variable. From the current unit, set occupied cell to the target cell. Set the current cell that holds a unit base to empty unit base. Add a function named mergeUnit. Use the target unit variable to call the upgradeUnit function. Use the current cell to set occupied unit base to empty. Then destroy the current unit. Add a function named swapUnit. Use current unit to call setActorLocation. Then use the cell location that target unit stands on to set the new location. Use the target unit variable node to call setActorLocation and use the cell location that current unit stands on to set the new location. After we swap positions, use the current cell variable to set occupied unit from the target unit variable. Then use the target cell variable to call setOccupiedUnit and set current unit to the unit base input. Now use the unit base from the target cell to set occupied cell to the target cell variable and use the unit base from the current cell to set occupied cell to the current cell. Add a function named processUnitPlacement. Use the target cell variable to check from the canMove to empty cell node. If it's true, call the move to new empty cell function. Do another check from the false output node. Use the current unit variable for unit 1 and the target unit variable for unit 2 in the kin merge unit node. If it's true, call the merge unit function. Do another check and do the same with the merge function, but with the kin swap unit check node. If it's true, we call the swap unit function. Add a new function named on unit selected. Add two input function variables, one as unit-based variable type named selected unit, and another variable of type vector named world location. Set the mouse location variable with the world location variable input, and set the current unit variable with the selected unit input. Check if current unit is valid. If it is valid, set the current cell variable with the cell that current unit stands on. Now use the current unit variable to set actor location with the mouse location variable X and Y. I set the Z-axis to 200 because I wanted to lift up when selected. Then do a check. Use the mouse location variable and wire it into the get cell from world position node. Then check if it's valid and check if current cell is not the same cell that we get from the mouse location. If it's true, set the target cell variable with the output of get cell from world position node. Then check if target cell has a unit base that is valid or not. If it's true, set the target unit variable with the output of unit base from the target cell variable. If it's false, we set target unit and target cell to empty. Add a new function named resetCell in unit. We set current cell, current unit, and target cell variables to empty. Add a new function named setUnitsCollision. We call this function to prevent collision when we drag a unit onto another unit. We don't want the mesh to collide with another unit. Use the gridCellsArray variable to call the for each loop node. Then check if the cell has a unit occupied or not. If it's occupied, we call the setCollisionEnabled function from the skeletal mesh in unit base. Add a new function named onLeftMouseRelease. Check if target cell is valid and it's not equal with current cell. If it's true, call the process unit placement function and call the reset cell and unit function. Set collision to enabled. If it's false, set the current unit actor location to the current cell that it stands on. Then call reset cell and unit and set unit collision functions. Create a game mode for our world setting. Create a player controller and set it in the game mode. In the player controller, set Show Mouse Cursor to True. In Event Begin Play, spawn the Grid Manager actor and promote it to a variable. Add a new variable of type Boolean named isMouseHold. Add a new variable of type unit base object reference named holdingUnit. Create a left mouse button event. When pressed, set isMouseHold to true. When the left mouse is released, set isMouseHold to false. Then check if holdingUnit is valid. We call on left mouse release function from the Grid Manager. Call the reset cell state function from the Grid Manager. Then set holdingUnit to empty. In Tick Event, use the isMouseHold variable to check. If it's true, we use line trace by channel with trace. Use the getPlayerController node to call the getMousePosition node. Then use the getPlayerController node again to call the project screen to world node. Wire mouse location X and Y into screen X and screen Y. Wire the world position output node into the start of the line trace. Then use the world direction output multiplied by 50,000. Then add with world position output and set it into the inline trace. If the line trace blocks, promote the hit location into a variable. Create a sequence node. In sequence 0, use the hit actor to cast to unit base. Do the check. If holdingUnit variable is not valid, we set the holdingUnit variable with the output cast unit base node. Use the Grid Manager variable to call the setUnits collision function and set type to no collision. Call the onUnit selected function, then set holdingUnit and hit location into it. Call the highlight cell state function. In sequence node 1, check if holding unit is valid. If it's true, call the onUnit selected function from the grid manager and set holding unit and hit location into it. Create a space keyboard event to spawn a unit. Now let's test it. The unit already drops into the cell, but I can't select it because we need to set the skeletal mesh collision to block all. Now I can select it, but it's hard to know if the unit is merging or not. Let's create a UI for updating the unit level. Here's a simple UI we set up that only has text. I set the text color to blue and set the text component as a variable. Add a custom function named updateLevel. Use the level text component to call the setText function. Drag the text input into the input function. In the unit base actor, add a widget component. Assign the widget class to our UI class. I set space to screen and set draw size to 100. In begin play, drag and drop the widget component, then call getUserWidgetObject and cast to our UI class. We can call our custom function updateText and set the unit level variable into the text input. Copy it and paste it into the upgrade unit function. After that, we can spawn the Niagara system and play the sound. Niagara system spawn location is really off from unit base. And if we spam the spawn button, it will cause overcrowding and get an error. Let's fix it. In the spawn unit function, after we promote with empty cell, we need to check if empty cell is valid. There's another problem. When a unit is at max level, it stands on top of each other. Let's fix it. In the process unit placement function, in the final false pin, use the current unit variable to set actor location, then set it to the location of the current cell that current unit stands on. When we spawn a unit, I want to play a sound. Let's go to the spawn unit function and implement that. When spawning the Niagara system, we need to change from spawn location to stand location. Now everything works fine. If this video helps you, please like and subscribe to the channel.